Okay, so this will be our last video here with a few more examples. I say a couple more examples from 6.4 because I know there's a lot of computations, and so it does good to see a few more. So these are our extra examples here. So first I have a given matrix Q and A. So this is Q, which we know from what we've talked about that is a orthonormal basis, okay? And you can eyeball it here and see that if you do the dot product between these two, you're going to get -5, +5, -3, and +3 all make 0. And if you go down one column here, you're going to get 5 squared is 25, 1 squared is 1, 3 squared is 9, 1 squared is 1. So I'm looking at 25 and 11 is 36 over 36 squared. So 36 over 36 is 1. Now we get the same thing there in the second column. So this is an orthonormal basis for the matrix A, okay? So I know A can be factored into Q and R, okay? And we know since Q is an orthonormal basis, I can multiply by Q transpose on the left. And since Q is orthonormal, I know Q transpose Q will give me the identity. So R is going to equal Q transpose times A. That will get me R, okay? So I need to multiply that then. So let's write what Q transpose is. Q transpose times A. So Q transpose, remember, you turn the rows into the columns and the columns into the rows. So my first column here is going to become my first row. 5/6, 1/6, -3/6, and 1/6. Second column becomes a second row, -1/6, 5/6, 1/6, and 3/6. Okay, and we're going to multiply that by matrix A, which is 5, 9, first row, 1, 7, next row, -3, -5, and then 1, 5. Okay, so I'm multiplying. So R then is going to be this product. Okay, so first row, first column, I've got 25/6. 1/6 makes 26/6. -9/6 makes -9/6. 26 minus 9 is 17/6. Then 1/6 here, I'm going to have 18/6. Okay, 18/6, right? So 25, 1 makes 26, -9 makes 17, plus 1 makes 18/6. That is 3, okay? First row, second column, I've got 45/6, plus 7 makes 52, minus 15 makes 37, plus 5 makes 42, 42/6, that's 7, okay? Second row, first column, so -5 and 5 makes 0, -3 and 3 makes 0. We know R should be triangular, so that's good. Second row, second column, that's -9 plus 35 is 26. Minus 5 puts us at 21. Plus 15 puts us at 36. That is 6. And so there is my matrix R. Okay? So I can easily do that multiplication. If I know the matrix Q and the matrix A, I can find R. And now I have a factorization for A. Remember, A is equal to Q times R. Okay? And it's a very useful factorization because it's based on an orthonormal basis of the matrix A, right? The column space here of A, this has the same basis, okay? Found that basis off screen, so to speak. That basis is given to you here. But if I have an orthonormal basis for A, that spans the same space that this does over here. So that's why this is particularly useful, because I can use that orthonormal properties to help me, okay? All right. So our second example here, we're going to do a big, long Gram-Schmidt so that we're ready for it here. So I'm going to find A, Q, and R for the R3 basis. So I have this R3 basis given to me here. Okay, they are not orthogonal right now, okay? Right, because 1 times 3 is 3, plus 1 gets us 4, plus 0, still 4, not 1. Okay, the dot product between them is not 1. Okay, now the dot product between the first and third vectors is 0, which is good. Okay, that means they're orthogonal. Okay, the second and third vectors, not orthogonal. So first and second, not orthogonal. Second and third, not orthogonal. Well, I'm going to do the Gram-Schmidt process. So GSOP, Gram-Schmidt orthogonalization process. I'm going to go ahead and label these vectors as x1, x2, and x3, so I know what they are. Okay, and so x1 is going to simply be v1. Okay, if it's easier for you, maybe you write v1 is equal to x1. Right, that means the same thing. So in this case, that is going to be 1, -1, 0. Okay. All right, so we're ready to take on v2 here. v2 is going to be x2 minus the projection. So remember what the projection is. It's x2 dot v1 divided by v1 dot v1 all times v1. Okay, so x2 is 3, -1, and 8 minus x2 dot v1. So I'm doing 3 times 1 is 3. -1 times -1 is 1. That gets me 4. 0 times 8 is 0. So I get 4 to the top. Okay, my denominator then, v1 dot v1. So that's 1, 1, and 0. So that makes 2. And we're going to multiply that times v1, which is 1, -1, 0. Okay, 4 divided by 2 is 2. So that makes that a little easier. Nice whole numbers here. Minus, okay, this is going to be 2 times those numbers. So I'm going to have 2, -2, and 0. Okay, and I can subtract those. So 3 minus 2 gets me 1. -1 plus 2 gets me 1. And 8 minus 0 is 8. Okay, so v2 equal to what we just found, 118. Okay. Now we're ready for v3. Okay, v3, remember, is going to be x3 minus its projection, but its projection has 2 components. So it's x3 dot v1 over v1 dot v1 minus x3 dot v2 over v2 dot v2. Okay, the first one's times v1, the second one's times v2. Let's fill in what we've got here. So I've got x3. x3 is 0, 0, -1. Minus, okay, x3 dot v1. So 0 times 1 is 0. 0 times 1 is 0. With -1 times 0 is 0. So I get 0 over, I already know v1 dot v1, so I'm going to go ahead and write it down. But ultimately, that's not a huge deal because it's 0, okay? And again, I'll go ahead and write v1 down since I already know it. But since it's going to get multiplied by 0, that's going to make things a little bit nicer for us. Minus, okay, x3 dot v2 now. So x3 is 0, 0, and then -1 times 8 gets us a -8 for the numerator. Okay, denominator then is going to be v2 dot v2, so that's 1, 1, and 64, so that makes 66 for the denominator. And then we're going to multiply that times v2, which is 1, 1, and 8. Okay, so let's keep going. I've got 0, 0, -1. This whole vector goes to 0, so we don't even have to worry about writing it down. Okay, 8 over 66 is 4 over 33. Okay, so I'm going to have minus 4 over 33, but notice it is negative. 4 over 33, but again, it is negative. And then 4 times 8 is going to be 32 over 33. And again, it is negative. So all of those are negative numbers. Okay, because of the -8 here. All right. Well, we're almost there. So I've got 0 plus 4 over 33. So that's 4 over 33. 0 plus 4 over 33. So that's 4 over 33. And then I have -1 plus 32 over 33. So that is going to just leave me with -1 over 33. As if -1 would be 33 over 33. So 33 minus 32, -33 plus 32 gets me -1. So -1 over 33. And remember that we like non-fractions, so we're going to convert this by multiplying it by 33, because we know I keep orthogonality if I multiply by a scalar that isn't 0. which is what we can do here by multiplying by 33 and just get 4, 4, negative 1. Okay, so that is my orthogonal basis. Okay, so the span, I have my 3 vectors I found: 1, negative 1, 0, 1, 1, 8, and then my last one, 4, 4, negative 1. The span of those vectors gets me R3, just like my original vectors did, but now these 3 vectors are orthogonal. Okay, so I have 3 orthogonal vectors, but in order to find Q, I need to find their norm. So I'm going to divide by their norm. So I need the norm of V1. Okay, 1 squared, and then the square root, so it's square root of 2. Norm of V2, 1 squared, and 8 squared, so I get square root of 66. 1 plus 1 plus 64. And then the norm of V3, 4 squared is 16, 4 squared is 16, and 1 squared is 1. So 16, 16, and 1 is going to make the square root of 33. Okay, so my orthogonal basis, which I can use to write Q, okay, is going to be 1 over the square root of 2, negative 1 over the square root of 2, 0, 1 over the square root of 66, 1 over the square root of 66, and 8 over the square root of 66. And then the third column, I'm going to have 4 over the square root of 33, 4 over the square root of 33, and negative 1 over the square root of 33. So there's my matrix Q. Okay? So let's go back and look at our first example here, right? So I had this A times QR idea. Okay? So I've got Q. Okay? Get this where you can see it all at once, hopefully. Play with my camera a little bit here. So I've got Q. Okay, I've got Q here. A, remember, is going to just be our matrix that we started with. So what were the vectors we started with? 1, negative 1, 0, 3, negative 1, 8, and 0, 0, negative 1. Okay. Then I'm going to rewrite Q here. I know that's going to take me a bit, but I want them on the same piece of paper for you. That'll just make it easier to interpret. 1 over the square root of 66, 8 over the square root of 66, and then the third column, 4 over the square root of 33, 4 over the square root of 33, and negative 1 over the square root of 33. Okay? So that's what we found for Q. Okay? A was given originally. So now if I'm going to find R, remember, A is equal to QR. Okay, which means I can take Q transpose of both sides. So I get Q transpose A, Q transpose QR. Q transpose Q is the identity because this is orthonormal, right? We did GSOP to get orthogonal, then we divided it by the norm to make it orthonormal. Okay, so that's the identity. So Q transpose A is what I need to do to get R. Okay, so let's write what Q transpose A would be as a product. So again, your rows become your columns, and your columns become your rows. So I'm going to have 1 over the square root of 2, negative 1 over the square root of 2, 0. Second row, 1 over the square root of 66, 1 over the square root of 66, and 4 over the square root of 33. Oh, I did that wrong. 8 over the square root of 66. All right, get off my direction there, right? We're turning the column into the row. Sorry about that. And then the third row becomes the third column becomes the third row. There's my 4 over the square root of 33, 4 over the square root of 33, and negative 1 over the square root of 33. Okay, we're going to multiply that times A. 1, negative 1, 0, 3, negative 1, 8, 0, 0, negative 1. Okay, and this is going to give us R. Okay, so we're going to do R here. First row, first column. 1 over the square root of 2. Plus 1 over the square root of 2 plus 0. So I got 2 over the square root of 2. Okay, 1 plus 1, so 2 over the square root of 2. Okay, first row, second column. 3 over the square root of 2 plus 1 over the square root of 2. So I've got 4 over the square root of 2. and then plus 0. I didn't say the plus 0. Let me try to clear up that picture just a little bit for you. Should look a little nicer. Okay, 4 over the square root of 2. First row, third column, 0, 0, and 0. Great, we like that. First row, third column. Okay, second row, first column, 1 over the square root of 66, minus 1 over the square root of 66, and 0. Okay, good. Second row, second column, 3 over the square root of 66, minus 1 over the square root of 66, plus 64 over the square root of 66. So let's go back to what we had. I got 3 minus 1 is 2 plus 64. So I've got 66 over the square root of 66. And then second row, third column, 0, 0, and negative 8 over the square root of 66. Okay? So third row, first column, 4 minus 4 and 0. Okay? 12 minus 4 minus 8, that's still 0. And then the third row, third column, 0, 0, and then 1 times a negative 1. Negative 1 times negative 1 will be a positive 1 over the square root of 33. And so there is my matrix R. So I found Q, A, and R given the basis that I started with. All right, I started with that basis, x1, x2, x3. Here is Q. A is easy. We just write down the vectors. And then I multiply to get R. So Q is your orthonormal basis that you find using the Graham-Schmidt process, okay? The Graham-Schmidt process, it's very important that you are patient, take your time, make sure you keep your signs straight, okay? There's a lot of different little multiplications in there, but ultimately it's just all arithmetic, okay? There's a lot of places you can have plus, minus, things like that, okay? So just be careful, okay? So I'm going to bring myself back on camera here for just a second at the end of our video here. So this is the last video for the term, the end of section 6.4. Again, please contact me if I can help you prepare for any quizzes, tests, whatever it might be. Okay? Take your time, work hard, make sure you get all the way through the homework. Don't hesitate to ask for assistance if I can provide it for you. Okay? Again, contact me if I can help. Thank you for paying attention and going all the way through these videos. And if I can be of any assistance, please do let me know, and I will talk to you soon.